Good morning, students. Today I am going to take a factors affecting a rate of reaction, which means factors influencing the rate of a reaction. So you are just seeing that four factors which will affect the rate of a reaction, influencing a rate of reaction. So the first is catalyst, the second is temperature, the third is concentration, and the fourth is nature of the reactants. So now see this. If you take that rate of reaction, whether it is a changed or not, so the rate of a reaction can be changed. So for an instance, so the iron get rust faster in an acid than in water. So the important factors that affect the rate of reactions are the surface area, concentration, catalyst, pressure and temperature. The first is nature of the reactants. So if you just take an example of sodium reacting with a hydrochloric acid, so the reaction is faster when the nature of the reactant, whether it is a strong acid or weak acid. So the reaction of sodium with hydrochloric acid is somewhat faster than that with an acetic acid. So do you know why it is happen? So that hydrochloric acid is stronger while compared with an acetic acid. So this acetic acid is less reactive while compared with an hydrochloric acid. So stronger the acid, so the reactant here it is an hydrochloric acid is a reactant, so it will judge the factors that will influence the reaction in nature. So the reaction takes place faster when it reacts with an hydrochloric acid. So the next is concentration. So concentration, it's changing the amount of reactants also increases the reaction rate. So the amount of a substance present in a certain volume of a solution is called in concentration. So that if the amount of substance is present larger means that is said to be in concentrated. If the amount of substance present smaller means we call it as in dilute. So more the concentration, more particles per volume exist in it, so hence the reaction get faster. So that granulated zinc reacts faster than 2m hydrochloric acid than 1m hydrochloric acid. Here 2m it's nothing but a molarity, so the concentration of an hydrochloric acid. So here it is an 1m hydrochloric acid is less reactive than 2m hydrochloric acid. So the reaction rate will be faster in 2m, 2 molarity of an hydrochloric acid. So the next is temperature. So most of the reaction goes faster at high temperature because of adding heat to the reactants. So it provides energy to break down the reactions, to speed up the reactions. So calcium carbonate reacts slowly with hydrochloric acid at room temperature. When the reaction mixture is heated, the reaction rate increases. If we increase the temperature, the reaction rate also increases. Okay, so that the food and all kept at room temperature spoils faster than kept in the refrigerator. So the room temperature have an high temperature, so it reacts with the surrounding to make the food spoilage. In refrigerator the temperature will be slow, so the spoilage of food will be retarded. The reaction rate is lessened while kept in refrigerator. So the next is surface area of the reactant. So when the solid reactants are involved in a reaction, so that the powdered form reacts more readily because the powdered form they have a surface area larger. It increases the surface area while compared with the solid reactants. So it reacts more readily than that of a solid reactant. So that calcium carbonate, the powdered calcium carbonate is more readily reacts with hydrochloric acid than marble chips, because the powdering of a reactant, it increases the surface area and more energy is available on the collision of an reactant particles, such the reaction rate is increased. So the next is pressure. So that the pressure is very important factor. So that if the reactant or gas is increasing their pressure, increasing the reaction rate. So this is because on increasing the pressure, the reacting particles come closer and collide frequently. The collide means it move easily to each other oftenly. Okay, so if it oftenly move or collide with each other, the reaction rate will be faster. So if we increase the pressure, the reaction rate also increased, inversely proportional, not a directly proportional to the reaction rate, the pressure. So the next is catalyst or an inhibitors. So the catalyst is a substance which increases the reaction rate without being consumed in the reaction. So it will speed up the reaction only. It's certain reaction adding a substance such as catalyst, it speed ups the reaction. For example, if you take potassium chloride KClO3, if I decompose this into an potassium chloride and oxygen, but it is a slower rate. Okay, so the reaction rate is very slower, the slower reaction. If I add the manganese dioxide MnO2 acts as a catalyst, it increases the reaction rate. Okay, so if we add the catalyst, it will speed up the reaction to make the reaction much more faster when compared without adding a catalyst. So these are the 6 main factors that influencing a rate of a reaction. Thank you, students.